Hi, my name is Prescott Watson, and I'm here with my partner Nadav Gur here in San Francisco. We're here to talk about Port Power's workplace charging pilot.
Thanks for having me, Prescott.
Maybe take a step back and give people a background on what the pilot is.
The pilot was run with Hertz Leasing, Israel's Hertz franchisee. They have over 40,000 vehicles leased out to companies as employee cars in a market that is rapidly replacing ICE vehicles with EVs. And those companies who lease from them also want to electrify their fleets. And as employers, they are in charge of fueling the fleet. Today, they have fuel cards and people stop at gas stations. And the equivalent would have been either send people to public charging or find a different place to charge. Now, you cannot install chargers at people's homes. Most people live in apartment buildings. And so the smart place to put chargers at scale is at the office buildings. Now, doing that, operating that, managing that at scale is the goal of the pilot. We wanted to show that we can build a template for how workplace charging should be built, should be deployed, should be managed, and collect as much data as possible on how these fleets behave, how these drivers behave, what works, what doesn't work from a quantitative perspective, but also from a user experience, driver experience perspective, because these companies care about their employee experience.
Okay, I get the scope. How did you run the pilot?
We took a group of real life users, employees who had no experience with EVs before. In fact, a lot of misconceptions and range anxiety.
Naysayers, yeah.
Yeah, we built a managed charging system, a multi-layer system. We manage power, we control all the chargers, we identify the vehicles with cameras, but also we have a system on top that manages energy and makes sure energy is used as efficiently as possible. When we can, we take it from solar. When we need to, we take it from batteries. One of the things we did is we engaged with the drivers regularly. They could always ask questions, and we could survey them in real time about their experience, about issues, and so on and so forth. We ran that for 3 months with a group of 10 drivers, 10 electric vehicles, Chinese vehicles, by the way.
Very popular in Israel, yeah.
Yeah, Geelys and BYDs, and pretty good vehicles, to be honest. But relatively limited range. We really took the cheapest cars that we could to show that this works.
You talked about managing power with solar and batteries. What you're describing as a microgrid. Mm-hmm. What did you actually build on the site?
So we built a managed charging and parking system. So we have chargers, but we also have cameras that identify vehicles, manage the parking, know who's where and who is where they're not supposed to be. We integrated that with solar generation, with the utility, and we built a microgrid running the whole thing, which also allows us to integrate battery storage. And we built user interfaces both for site managers. There's a system where you can see the site in real time, you can see who's charging where, you can see all the metrics, and a texting-based system for the drivers where they can get information about what's going on. They can ask questions, what's available in the site. They can check in, check out, get in a queue. They can really feel like the site will be waiting for them when they get there, and the car will be waiting fully charged when they need to leave for home.
So what's your biggest takeaway having run this when you look at how charging is done today at most workplaces or anywhere in the US versus what you've demonstrated at those parking lots?
We have conclusions or learnings on 2 levels with 2 audiences in mind. So the first one is about infrastructure, how to build and run and operate this infrastructure. So I think a simple conclusion is that in a way, level 2 charging for workplaces is overpowered. You do not need 6 or 10 or 19.2 kilowatts when your driver is probably going to be there for 4, 6, 8 hours and probably come with on average 50% battery in the first place. So intelligent charging allows you to optimize and deploy many more chargers so your employees don't have to come out of the office or wait or move cars or whatever. Secondly, we show that modular architecture works, and this is very important because if you have hundreds of vehicles parked at your parking lot today, maybe 10-20% of them are electric. But 5 years from now, it's going to be 30, 40, 50%. And 10 years from now, it's probably going to be most of them, if not all of them. So you want to be able to build your infrastructure over time. We have built a modular system that expands over time. We can add chargers, panels, cameras, sensors over time and support more vehicles without going into another construction project, breaking more walls, breaking more concrete, and so on. Finally, and this is really important, malfunctions happen. It could be the car, it could be the charger, it could be the cable. If you operate the system over time, things will happen. And so having a two-level system where if you can't control things at the charger level because something is broken, you have a level on top of it, the microgrid level, we can say, let's take just this charger out of commission, or let's restart just this charger or just this block, such that if they come online, great, system's working again without waiting for a technician, without waiting 2 days for the electrician to come or somebody to get on a plane, for heaven's sake. And if it is broken, okay, let's take just this one out of commission. So that two-layer system allows you to scale, operate, and maintain that infrastructure much, much better and actually cheaper than the way things are being done today. So that's on the infrastructure side. We've learned a lot of lessons that are relevant for whoever's managing the fleet. The first one was this transition is hard on drivers. People who haven't driven EVs before, they need assistance, they need support, they don't know how to do things. And frankly, they're just anxious. Range anxiety is a real thing. And if you have a tool to support them, to help them, then in a few weeks, you're in a much, much better place. But if you don't, people get stuck and they will say, I'm going back to an ICE car, I'm never driving an EV. So you want to have this capability as part of the system. Secondly, the numbers don't lie. You move to an EV fleet, you save 80-90% of the cost of fueling that fleet. And we did that with vehicles that are actually cheaper than the average vehicles that they drove before. Electricity is that much cheaper as long as you're charging on your own site and you're paying utility rates and you have some control over where that energy is coming from. If you are going to try and do that on public charging, you will not have the cost savings and you will be wasting a lot of your employee time. There's a lot of money to save, but you got to control your own infrastructure.
That makes sense. Okay, the employees have their EVs, pilots run its course. What's next for Port?
What we're doing now is we're productizing the system into a product that is useful for all sorts of light-duty fleets, everything from employees driving passenger cars to their office, but also last-mile delivery fleets, van-driven transit fleets. And we're basically seeing two kinds of companies participating with us in bringing this product to market. One is fleet leasing companies like our customer who are basically being asked by their customers to provide this kind of infrastructure alongside the vehicles. And they get to now participate in the energy side of things and not just in the vehicle side of things by leasing these systems out to their customers alongside vehicles. The other kind of players who are involved in this and who are very active in the space actually are big commercial real estate players. They are seeing these energy resources and these energy outlets, if you will, as new assets for them to develop and manage on top of their existing properties. So distributed energy resources like solar and storage and outlets like EV charging and providing electricity to data centers and offices.
That's something I don't think people fully understand. Like, why is commercial real estate interested so much in this?
It's a very good question. The answer is simple. Providing energy to vehicles is $600 billion business in the U.S. This is the size.
Today,
this is gas stations. $600 billion a year are being spent at gas stations, and the gas station model does not work for EVs. 80% of what EVs are going to get is not some fast charger on the highway. It's either in the home or in the workplace. And so, if you can be the owner of that infrastructure in the residential or commercial property where the vehicles are charging, you are going to participate in that $600 billion market. And this is a great market to make money in. So by putting advanced managed EV charging in your property alongside your other energy assets, you are going to grow your commercial real estate business. And we're seeing very big, very smart groups in commercial real estate realizing that and essentially becoming energy suppliers for their tenants.
So the future of CRE is almost like being an energy company.
CRE is seeing this, and these companies are becoming infrastructure companies, which is natural to, that's what CRE is about in other ways.